Hi, my name's Tristan Wood. I'm the MD of LiveWire Digital, and I'm going to present a presentation that was put forward at the Integrated Transport Systems Conference in Strasbourg. The presentation is covering integrating cellular, terrestrial and satellite services and making them available to autonomous and connected vehicles. So let's have a look at the problem space. Consider an intercity train. It starts off with good 4G coverage in the city. This then degrades to 2G, limiting communications, halting telemetry and frustrating onboard travellers. There may be 4G coverage from a different provider, but it cannot be used as there is no agreements in place. The train then speeds through a station which provides brief Wi-Fi coverage, and it then hits a black spot. No cellular coverage at all. So let's introduce a satellite service to augment the terrestrial services. By using cellular, terrestrial and satellite, we can have coverage, but how can we integrate these services? This is a headline objective for 5G and the basis for LiveWire Digital developing RazorLink smart networking. There is more and more demand for seamless communications from vehicles. There is a wide choice of networks, but they are independent and in competition with each other. There is also a move towards cloud services and the proliferation of smartphones and tablets. The general practice is that the network is selected based on cost, bandwidth, QoS and location. Selection is often manual, complex and highly disruptive. There is a clear demand for an integrated communications service. The problem can be addressed using software-defined networking that decouples the application from the underlying network structure. Smart networking is not restricted to a specific communication technology, and it is agnostic to service providers. It can readily augment existing services with new or private communications links, such as radio, mesh networks or new satellite services. So what are the necessary features? Well, first of all, we want to improve application behavior as the vehicle transitions between different networks. We need faster upload and download, especially over challenging networks. Now, the use of public networks like Wi-Fi hotspots demands good security, so we need to be able to encrypt the data over any network, but without compromising performance. Communication services cost money, so it's important to be able to use the most cost-effective network when that's available and still use others when the demand arises. Critical data must be delivered first, especially if there is limited bandwidth. The demand for bandwidth is high, so combining the available bandwidth efficiently is also a key feature. So let's look at the features in more detail. TCP connections and UDP flows break when a network is switched and the IP addresses change. RazorLink maintains the IP structure as underlying networks change, so the application is unaware it is operating over a different network. Most applications use TCP, which can be adversely affected by the properties of wide area networks. Bandwidth may be available, but cannot be utilized. RazorLink provides WAN optimization to maintain the best performance and link utilization. Security is crucial. It is often addressed with VPN technology, but this has detrimental impact on performance and restricts the implementation of other features like WAN optimization. The RazorLink security methodology works in conjunction with the other features, offering private shared keys and AES encryption. There are various factors to consider when selecting a network: pragmatically, cost and availability. However, other factors like geolocation and the correlation with the QoS required by a particular application. The majority of applications can operate under a transparent best effort policy. However, real-time information or critical telemetry must be delivered ahead of background communications. As such, applications can request a specific QoS from RazorLink and get back network statistics. The ability to aggregate networks offers a seamless transition as networks come and go, but it also addresses the key requirement for more bandwidth. RazorLink can agnostically bond networks of different types and providers. RazorLink Smart Networking has two endpoints. One is at the mobile and connects the vehicle's onboard network to the network services. The other forms part of the fixed infrastructure, for example within a corporate IT structure or private cloud. LiveWire Digital has been awarded a contract by the European Space Agency to migrate RazorLink Smart Networking to a public cloud service, integrating with back-end authentication, service definition and billing mechanisms. This makes it possible to move the service into a telco's network or into a vehicle manufacturer's cloud service offerings. Looking at the mobile endpoint, RazorLink is cross-platform software that can run on Windows, Linux, OS X, and can be readily ported to real-time operating systems. It can be installed on PCs, be built into smartphone apps, deployed as a transparent router, or be incorporated into communication systems for autonomous shipping, blue lights, trains, etc. It can even be built into communications equipment like modems or even satellite terminals. So what are the benefits to integrated transport systems? A comprehensive solution combining all the necessary features to integrate wide area networks. The solution is software that can run on commercially off-the-shelf hardware, such as an Intel NUC or even a Raspberry Pi. It delivers the seamless connectivity necessary for connected and autonomous vehicles. Good communications are the foundation for cloud and web services. Reliable and secure communication touch all aspects of future transport systems. For the end customer, fast access to the internet is considered essential. If you'd like to find out more about RazorLink Smart Networking, there's further information on our website at www.livewire.co.uk.